Hello everyone, this is Nazeer from the Faculty of Civil Engineering Technology. Welcome to all of you in Canada and around the world. When we look at what I have on the screen here, it is just a review of what an ellipse is. It's sort of an egg-shaped type of figure, and of course you see the equation right in that location there. And I'm just going to switch to laser pointer here. Yeah, that's what we have in here. And let's go through the parts of it, and if you want more of a detailed explanation, my previous video does do that in a little bit more detail. The first thing that we have to realize about the ellipse is that it has two axes. One is the major axis, which is the longer of the two, and from the center to the vertex is called A, and 2A is the entire length of the major vertex. So we have the major vertex and or the major axis and the vertices. When we look at the minor axis, which has co-vertices, and we have the same sort of situation. We have a perpendicular right here. They meet at a perpendicular. And we have this is called a co-vertex, and this is the minor axis. It's designated in the formula as B right there. And that's basically it. But there's a unique thing about the ellipse also, is that it has two foci, plural form of focus, and of course because these two axes meet at a perpendicular, if you join the co-axis to the focus, that makes this a right angle triangle, right? And one of the phenomenon of a right angle triangle, this hypotenuse is the exact length of 1/2 of the major axis, which is A. So we label it as A prime so that we could actually distinguish between the two. And when we look at the minor axis, it is 2B, or not to be. There you go. And there it is. It's 1/2. B is 1/2 of the minor axis. Let's, like I said, if you want more of a detailed explanation, go to the previous video. When we look at this particular equation that I'm circling right now, this equation is for the ellipse with its center at the vertex at 0, 0, right? And the reason why I know that is because there's no h or k value here, right? I have here a squared or b squared, right? A squared or b squared. The reason why I wrote it in this fashion, it tells you about the orientation of the major axis. If the major axis is under the x, then your major axis is parallel or on top of the x-axis. Because this doesn't have h or k, I know that the center of this is at the origin, right? So we know that. If this is a squared is on the x, then you have the major axis horizontal. It's the longer of the two axes. And basically that's it for this. You just have to recognize that there's no h and k, like we're going to discuss in this formula. And that means that this center of this ellipse is at the origin. When we look at this equation now, we see that we have an h and k, and h and k is the coordinate of the center of the vertex. But anytime that we plug h and k into the formula, we have to, the sign automatically changes. The sign automatically changes, right? And again, a or b, depending on which one is here, the larger of the numbers of the denominator, the larger of the number of the denominator will dictate the major axis or the minor axis, right? So these are the two equations. When we look at the x and y here, it's a point on the ellipse. We already know that the center is h and k, but the x and y is a point on the ellipse, and sometimes we use that when we're solving equations, right? So let's go to the next one. And when we look at this, if you're given this, it says plot the shape, right? So the first thing that I have to do is analyze this. The thing that I'm looking at, I have h and k. I am not at the origin. The center is not at the origin. I do my major axis because this number is larger than this denominator. This is 7 and this is 3, because remember these are square terms, right? I know that my larger axis or major axis is parallel to the x-axis because it's sitting on the x, and my minor axis is going to be parallel to the y-axis. So I know a lot of things about this already. I know this the coordinate of the center, I know the A, I know B, and I could figure out C from Pythagorean theorem. Let's go and look at that. This is the form that this formula came in, right? H and K. This is the form that was given here. The line of symmetry is parallel to the x-axis because this number is larger, right? This number is larger. It's parallel to the x-axis. And then when we look at this again, we could go and pull out the center coordinate. The abscissa will become from -5 to +5, and the ordinate will become from -6 to +6. And then we have A and B. We could use Pythagorean theorem to solve for C when we get there. So when we take the root of 49, we get 7. We're going to go plus or minus 7 from the center, and this will be the same. It'll be perpendicular though. Let's go and use Pythagorean theorem to solve for C, and C, remember, is the distance from the center to the foci, right? So it's the distance from the center to the foci. So we need that to plot the foci of the ellipse. So we know everything now. We could plug in directly from this. A squared is 49 and B squared is 9. In this particular formula, the hypotenuse is 8, right? When we looked at it in the previous slide, the hypotenuse was 8. So we're looking at, or A prime, you could say that too. We're looking at 49 minus 9 will give you 16, and of course the root of 16, oh no, it's not 40, it will give you 40, and root of 40 will be 4 times 10, so you could take out the 2 plus or minus that. So that is all the information. We have A, B, and C, which we need, and of course we're going to go and plot this up. We're going to start with the center coordinate. We're going to plot that first. Well, maybe we'll plot it all first, right? The center coordinate is right there. We know that it is parallel to the x-axis because of this guy, and of course we know that A is plus or minus 7. So I'm going to take the center coordinate, and I'm going to look at 5, which is the x. I'm going to plus 7 to that, to 5. I'm going to get 12. And then I'm going to take 5. I'm going to subtract 7 from that. I'll get minus 2. I'll plot those points. That's my major axis, right? That's my major. From the center again, I'm going to go to plot my co-vertices, which happens to be B is plus or minus 3. So I'm going to go in the y direction. So I'm going to add 3 to 9. I'm going to get that point, and I'm going to subtract 3 from 6. I'm going to get this point here, right? I add 3 to 6, I got 9, okay? Pardon me for that. And then I subtract 3 from 6, I get 3. So these are the co-vertices. I still could go and plot the focus because I know the C value, but let's go and put in some of this information. I'm going to go and place my translation axis right there, and then I'll put in my ellipse, and then I'll put in my foci on the inside along the major axis, right? So I'm going to plot those up, and of course I have to subtract this number and add this number to my x coordinate. 5 plus this will give you that point, and 5 minus this number will give you this point. And now you have the entire basically ellipse plotted, right? It asks for a plot, and it gives you an equation, and you had to go and decipher it. Let's see what else is there. We are given a bunch of points on this second example, and this it's given the vertex of the major axis. It's given the focus. It's given the center of the ellipse, right? The coordinate of these things. When we look at this, the unique thing about this, if you notice the ordinate of each one of these, the y value of the coordinate set, it's all 2, right? So if it's all 2, that means it's running horizontal somehow, right? But because we have a vertex, major, a foci, and then a center, we only will have 1/2 of the ellipse here. We could go from the center and plot the other half. It's symmetrical in that way. So we've gone and plot these things. We have the vertex, the focus, and the center. I could go and plot in these other ones by taking the distance from here to here. When we look at the x value is -5 and -2, so it's 3. If I'm going to go the opposite way, I'm going to add 3 to -2, it'll give me +1. And the distance from here to there, you're taking the difference of it, it'll be 5. So I'm going to subtract 5 from this, or I'm going to add 5 to that, it'll give me +3. Right? So that would be the other half of the ellipse. And we go and put in our translation axis, and line of symmetry is parallel to the x-axis. So because we know that these points, the major vertex or the vertex and the focus lands along the major axis, we knew that the line of symmetry was parallel to the x-axis. We also knew that the distance from the focus to the center, which is the difference between these two guys, will be 3. Plus or minus 3 will be the focus or the foci from the center. And then we know also from here to there, it's going to be 5, right? The difference of these will be 5. So A is plus or minus 5. Pythagorean theorem, again, we could use to get B. Okay, so we have to remember that. This is the form that it comes in. This is the hypotenuse. I've already taken that over to the other side. And I am going to rearrange it for B. Alright, so I've taken the B, made it plus. I bring over the C on the other side, make it minus, and take the root of that. And B is equal to this, what is down here. Alright, so B is equal to 5 squared, which is A, minus 3 squared, which is 9. Alright, so we have A squared and B squared under here, and that equals to, no, I gotta correct that. This is 5, which is A squared, minus C squared, and that will give us 16, which gives us plus or minus 4, which is our B. Again, there was I misspoke with that one. It was 25, which is A squared minus C squared, and that will give us plus or minus 4. Okay, so now we have that. Let's go and plot that up, and that's now in place. So when we look at that, we're going to go and plot the B now. We just took the distance from here to here and plot the, you could call it the symmetrical point from the minor axis, and the symmetrical point from there. It's just the same distance from here to here, from there to there, from the center to this point, from the center to this point. And now we know that B is 4, so we are going to have to more or less adjust the y value of the center and go 4. So if I were to add 4 to this, I'll get 6, and if I were to minus 4 from it, I'll get minus 2. So let's go and put that 6 minus 2. Now we could draw in our ellipse and plot the shape. It's asking us to plot the shape, so that's how we go ahead and plot the shape. And then when we look at this takes on the form, if we want to find the equation of this thing now, it takes on the form because the center of this is not at the origin. We know it's going to have h and k involved, right? H and k is these values here. This is h and this is k. When we go and write the formula, this is the the way that the formula comes out, and we're going to use this, and we're going to plug the 2 there. It changes sign, it becomes plus 2. The minus 2 becomes plus 2, and then when we take the plus 2 and plug it in there, it becomes minus 2. We put it in brackets just like it says there, and now we know our major axis, or A value, is the distance from here to there, right? The distance to, the difference between 2 and 7 is 5. 5 squared is 25, right? And then the distance B is the distance from the center to this co-vertex. So when we look at that, we're looking at the y values. 2 from 6 will give you 4. 4 squared is 16, right? So now we have the equation of this, and this is in the standard form of the equation, right? So we've come up from coordinate values, we've come up with the equation, the standard form of the equation. I could go and make it into the general form. I have to get rid of the denominators first. To do that, I have to multiply each one of these terms by 25 times 16. Now if I were to go and multiply 25 times 16, the 16, the 25, if I were to just, maybe I could write it on here, pen. And I'm going to do that with each one of these. So if I'm multiplying this, it'll cancel out with that. You're left with 16, which is right there. And if I go and multiply this here by 25 times 16, because I have to do it to every term, the 16 cancel out, you're left with 25 right there. And I have to do that to the 1 also. I have to go and multiply this by that. Well, when you look at 25, 4 times 25 is 100, 4, 4, 16, it'll give you 400 for that. It's right there. Okay, so that's how you you deal with that. But now we have a binomial squared and a binomial squared. We have to go and expand that. This is in factored form here, these two, so we have to expand it. To expand a binomial, it's called special products. You could just square the first term. The product of the inside times 2 will give you the middle term, and square the last term, which would always be positive because you're squaring it. If it was even negative, it would become positive. So you square the last term, which will give you plus 4. And we do the same for this, and this is what we get. Square the first term right there. Product of the inside times 2 give you the middle term, square the last term right there. And likewise here, square the first term, y squared. You have to carry the sign, the product, meaning minus 2y times 2 minus 4y, and square this, it becomes plus 4. And now I'm going to multiply each one of these, this trinomial by 16 and this trinomial by 25. Let's go and do that. So this will become 16x squared. 4 times 16 is 64 x, and 4 times 16 again will be 64, and these ones will work out the same way. We just multiply them out, and 64, 25, 4 times 25 is 100, so that's minus 100y, and then we'll have 100, and that's equal to 400, right? So now we're going to gather everything on one side, on the left hand side of the equal sign, and equal to 0, and we have it in general form. Remember, the general form does not have any denominators in it. When we look at this, we'll put it in descending power also. We'll take the x squared term, and then I will put the y squared, and then I'll put the x, 64x, and then I'll put the minus 100y, and we have 64 here, plus 100, 164. When this comes over, it'll be minus 400, so it'll be 236, I believe, minus 236 it'll be for that. And that's what we're getting. X squared, y squared, x, y minus 236 equal to 0. Sometimes I've seen in textbook where the x's are grouped together and the y's are grouped together. So you'll have x squared plus 64x, 25y squared, and then minus, but either way, it would be fine. Now that's another problem that's done there.